Okay, problem number 14 is a word problem that's about right triangles. So we've got a jet plane begins a steady climb and flies for 3 miles at an angle of 12 degrees with the ground. What was its change in altitude in feet? So I'm basically going to draw a little picture. We're going to start out with our plane. It's on the ground. Here's the ground. And our plane is going to take off and steadily inclines for 3 miles, which is 15,840 feet. And basically, this angle, this plane with the ground, I know you love my plane, makes a 12-degree angle with the ground. And the very last thing that we want to know is what's its change in altitude? Altitude in a plane, just like altitude in a triangle, it's that perpendicular, that right side. So that's our x. That's what we're looking for. So here we just have a triangle. It's a right triangle. We have an angle. We have a side. We have another side. I'm going to write that little node chart again. Always starting out with my angle. In this case, it's 12 degrees. X and 15,840 are my other sides. X is the side that's opposite my angle, so that's our opposite. And the 15,840 is opposite the 90-degree angle, which makes it our hypotenuse. We have an O and an H. Back to our SO again, so our sine, and we're going to write our expression. The sine of the angle equals opposite x over hypotenuse 15,840. To get x by itself, we want to get rid of this denominator, so we're going to multiply both sides by the 15,840. And we're going to put it in our calculator exactly once. So we've got 15,840 times the sine of 12. Close parentheses, hit enter. That gives us 3,293.3211 feet. Be sure to put those units as they are in the word problem. For number 15, we kind of skip ahead to area and perimeter. And we have a regular hexagon. How many sides does that have? That has 6 sides. I'm going to want to know that. And has an area of 96 root 3 and an apothem of 4 root 3. And we want to know the length of each side of the hexagon. So although we learned a lot of ways to kind of compute area of different objects, we did learn that the area can be found using this 1/2 a times p formula. And this can be used anytime we have a regular polygon. And this is regular, so we can use this formula. So I'm going to fill in what we know into this formula. We've got 96 root 3, that's our area, equals 1/2 apothem 4 root 3 times perimeter. Still don't know that. But the perimeter, since it's adding up all the sides, will help us find out how long each side is. So that's good. We're going to simplify this. We've got 1/2 4 root 3, which is just 2 root 3 times p, equals 96 root 3. If I want to get p by itself, I can divide both sides by the number that's being multiplied by it, which is 2 root 3. This is nice because those root 3's, they're going to cancel. And we're left knowing that 96 over 2, which is just 48, equals the perimeter. Now the perimeter is how long the sides are times how many there are. And in a hexagon, we have 6 sides, and so it's kind of like 6s, 6 sides. So now we know that our perimeter is 48, and that's 6 times how long the sides are. If I divide both sides by 6, 48 divided by 6 is 8. So the side is just 8 units long.